In this lesson, we're going to discuss solving absolute value equations and inequalities. Remembering that the symbols we have for equations is just the equal sign that says that two statements are of equal value. With inequalities, we're going to have two statements that either one is greater than the other, or one is greater than or equal to the other. We have the is less than symbol. We have the is less than or equal to symbol. And don't forget, we could also have the is not equal to. We could have two statements that are not equal to each other and solve what would make that true. The first part of the lesson is going to be on equations. So we have this statement here that absolute value of 3x minus 7 is equal to 14. I want you to think about, we have a poster on the wall that talks about how we deal with a problem. And the first is we need to define the problem, then we'll explore the possibilities, then we'll apply an approach, and then we need to look back to make sure that what we've done makes sense. So in defining this problem, we need to think about what absolute value means. And absolute value means the distance from 0. So this equation is saying there's this 3x minus 7 that is 14 units from 0. So that's defining the problem. Exploring the possibilities would be to say, okay, if it's 14 units from 0, 3x minus 7 could equal negative 14, or 3x minus 7 could equal positive 14. Either one of these two statements would make this equation true. So we solve each of those equalities, and we get these two possible solutions. We double check that each one of those, when plugged back in, do in fact work. That's the look back part. Just do your mental math and you can double check that both of these solutions do work. Remember, they're connected with an or. It means either one of these makes the original equation true. The next part to finish this up is we need to graph it. So we could graph a number line. Now this, I want you to look carefully at the way I did this number line. We've got all these little numbers down here, and we have to graph negative 7/3, which is somewhere between negative 2 and negative 3. It's actually negative 2 and 1/3, but it's very difficult to see on here. So I would prefer if you just put the two values that are the solutions on the graph. You don't need all the other tick marks. Just make sure that the number that's on the left is in fact smaller than the number on the right. Our solution set are these two values that we have in the equation form, and then the graph is just a graphic of the solutions. Let's look at another example. After we define the problem, defining the problem saying that x plus 3 needs to be 2x plus 9 away from 0, whatever 2x plus 9 is. So exploring those possibilities is that x plus 3 would be positive 2x plus 9 from 0, or x plus 3 would be negative 2x plus 9 from 0. Solving each one of those equations, we get that x equals negative 6, or x equals negative 4. But don't forget that last part, which is the look back. Double check that these solutions do in fact make this equation true. So here's the equation. I'm going to plug in the x equals negative 4. We will evaluate the left side and the right side, and we find that the left side and the right side have the same value. So x equals negative 4 is a solution. Now we plug in the other value, x equals negative 6, and we find that we get a false statement. We get 3 equals negative 3. Since this is a false statement, we know that x equals negative 6 is not a solution. It does not make this equation true. So in fact, there's only one solution here. The other one is an extraneous solution, and we can graph the one solution on a number line. Now let's look at the next part of our lesson, absolute value and inequalities. There's two different cases, and one is when we're using the greater than symbols, either the greater than or the greater than equal to symbol. The other case is the absolute value where they are less than some value or less than equal to some value or expression. In case one, let's look at the simplest of cases where we don't have to really add or subtract to look at this. We need to define what this means. So what does the absolute value of x is greater than 5 mean? It's asking us what values are more than 5 units from 0. Not exactly 5, but more than 5. Well, 5 is not more than 5, so we have to look at this as an open hole, saying not at 5, but it is everything to the right of 5, every number above that. But similarly, negative 5 is 5 units from 0, and everything to the left of that. Now that we can see this graph, it's easier to write the inequalities. We have 2 inequality statements, and our question is what word goes between, or what connecting word. We had the choice of either and or or. Well, an and statement would be where do these two intersect, and they don't intersect at all. Both of them are true. This is true and this is true. They don't intersect. It's an or statement, and in fact, that helps us understand that all greater than symbols will be connected with the word or. And so that's something to remember, that when you have absolute values that are greater than something, you will have a connecting statement of an or statement. So the final solution is x is less than negative 5 or x is greater than 5. And those two sets will make this statement true. Here's the next one. X minus 3 is more than or exactly 1 unit from 0. So we draw this graph, and this is not the solution to the graph. The solution to the inequality. This is just thinking about what it means. This is the D. This is the define the problem. I'm defining that this is what that inequality statement is saying. So once I've defined the problem, I can write my two possibilities. I'm exploring my possibilities, solve each of those possibilities, and then at this point, don't forget to do the look back of double checking that both of these x less than or equal to 2 actually makes this true. So you could plug a 2 and a 1 and a 0 in here and see that it does work. And on this one, there's a greater than or equal to 4, so you could try plugging in 4 and 5 and 6, and you could see that that's true. We therefore can graph this because we know we've looked back. We graph that x is less than or equal to 2, or x is greater than or equal to 4. And we have our solution, and we have the graph of our solution. The second case is looking at when absolute values are less than. And this is going to be less than, or we could be talking about less than or equal to. So first we need to define the problem. So once again, I'm just looking at this and saying that at 3x plus 4 is less than 7 units from 0. So between 7 and 0, all of these numbers are less than 7 units from 0. And from negative 7 to 0, but not including negative 7, those also are less than 0 units, less than 7 units from 0. So we can write an inequality statement. Again, we're wondering what's the connecting word. Well, these two sets will overlap, and we're only interested in this overlapping section, so that's the word and. So now we're thinking, okay, absolute values, whenever we have a less than symbol, will always have and as the connecting statement. We solve each of those. We need to make sure we do our mental math, that these values actually do work in here, the numbers between there. We then graph that inequality statement. It's the intersection of those two, and we're done with that. Some things to think about. I want you to think about, can an absolute value be less than a negative number? And in your thinking about that, solve this absolute value inequality. Remembering that you have an and statement. When you have a less than symbol, you will have an and statement. The next thing I want you to think about is, can an absolute value be greater than a negative number? And to help you with that, I want you to solve this inequality statement. 7x plus 18, the absolute value of that is more than or equal to negative 1. Remembering that a greater than or equal to or greater than symbols always give you an or statement. The next thing I want you to do is to graph these two, this compound inequality, remembering we have the word and so what does that mean about these two sets? And then I want you to graph, it's the same inequality statements, but this time they're connected with the word or. So I really want you to be looking at what's the difference between these two graphs of these compound inequalities. And that's the end of this lesson.